This is 3.3 Solids, Liquids, and Gases. So our outcome is I can represent the differences between solid, liquid, and gas phases using a particulate level model. So first thing you're going to do is go to this website and look at phase change, and you're going to uh, see the attractions that occur in a solid, liquid, or gas. So then we want to draw three diagrams that show the water molecules in different states of matter, making sure to indicate the relative strength of intermolecular forces occurring in each state. So in the solid, we're going to have very strong intermolecular forces. So those are going to be held in place. Those particles are held in place, but they're still able to kind of vibrate a little. So the intermolecular forces there are going to be very strong. In a liquid, the particles are still packed close together, but they're not packed in such a neat way and they're free to move. So those intermolecular forces are a little bit weaker. And in a gas, those molecules are widely separated, really far apart and moving at great speed. So those intermolecular forces are going to be very weak. So how do we change between different states of matter? So if you wanted to change solid water into water vapor, you would add heat. So adding heat is going to increase the kinetic energy of those particles, which increases their motion. This weakens those intermolecular forces and it allows that phase change to occur. When we're cooling particles, the kinetic energy is reduced, and those slower moving particles have more time to interact with each other, and thus they're going to have stronger intermolecular forces. So, why do gases take the volume of their container, whereas solids do not? So, gases have very weak intermolecular forces, and gas particles do not attract each other strongly. So there's a big distance between those particles. In a liquid or solid, those intermolecular forces are strong enough to hold the substance together. So in gases with those weak IMFs, they're not held in one place and they fill the available space. Whereas solids and liquids are held together by those strong intermolecular forces, and they're going to have similar volumes because the particles are in close contact at all times. So this is why you can easily compress a gas, but you can't easily compress a solid or liquid. So how is the motion of particles in gases and liquids different from what we see in solids? So in solids, those particles are locked into place by very strong intermolecular forces throughout the substance. So those particles can kind of vibrate in place, but they can't really move. In liquids and gases, the intermolecular forces are weaker, which allows more motion of the particles, so the particles are able to flow. So one of the assumptions of the ideal gas law is that particles do not attract each other. Could this be true? So no, because when condensation forms, water vapor has to be attracted to itself in order to condense into a liquid. So this assumption works for gases but not solids or liquids. And that's because in gases there are some intermolecular forces, but they're very weak. And depending on the conditions, we're going to see that that's generally going to be a fair assumption. Now, the Imf strength is low in gases compared to solids or liquids. And this is true for most conditions except for those that cause condensation. So think about what condensation means. Those gas particles have to get close enough together to form these intermolecular attractions so that they can stick together as a liquid. So in gases, there is some attraction between particles, but the strength is much lower than it is compared to liquids or solids. So conditions that cause condensation are high pressure. If you cram those gas particles together, they're going to interact more. And low temperature. If you reduce their kinetic energy, they're going to interact more. So behavior of solids and liquids is dominated by intermolecular forces and their ability to pack together. But intermolecular forces aren't as important in gases, because those particles are so far apart and they're constantly moving. So for a gas to behave more ideally, do we want to heat it or do we want to cool it? So if we heat it, this is going to weaken those intermolecular forces, which is going to mean more ideal gas behavior. Number 10, what factors affect the arrangement and movement of particles? So temperature, their kinetic energy, the strength of the intermolecular forces, as well as the ability of particles to pack together. What factors affect the collision frequency and spacing in gas particles? So that's going to depend on pressure, volume, temperature, and concentration. How frequently are they going to collide? So the reflection question, compare the spacing and motion of molecules and strength of intermolecular interparticle attraction for all three states of matter. So in our condensed states of matter, we're going to have strong interparticle attraction and less spacing and less motion than what we see in a gas.